Good morning, Dan from DJMoore Lofts, and today I'm going to go through the process of converting a truss roof for a loft conversion. So at this property here, we've got quite a large loft conversion that we're doing, creating 2 bedrooms and a bathroom up there. But it is your new, I was going to say traditional, but it's very much a truss roof, and it's nowadays the popular construction for a lot of builds. You don't get many cut roofs nowadays. I'd say 75 to 80% of our builds are truss roofs. So what I wanted to do is give you a little walk around. So stay to the end because we'll talk through fully on how to convert a truss roof and structurally that is. So yeah, let's jump up there. We'll have a little look and we'll see what the lads are getting up to, and hopefully we can show you some bits to understand. So firstly, we've had Lawson's here deliver all our windows. Well, I say windows, deliver all our products basically. So we've got our chipboard floor in there and we've got all our timber and so on stacked out nicely. Now, like I say, this is a big loft. So some scenarios might not necessarily work with some of the smaller ones, but the principles are the same. Right. Look at that. It's a monster. So, if you can imagine on this one, we've got what we call a spine beam. So we've got a spine beam there and another one there. Now the reason being is, if you can imagine, we've got a set of stairs in the middle. So if you was to run a gable beam from there all the way through, potentially it would cut through where the stairwell is. So what that would mean is the steel would have to go further back, which would potentially make the joist longer, deeper, because they would be longer. Structurally, the roof would have to change because instead of it being picked up 2/3 along the way, it'd be picked up right at the end. So then you'd need deeper rafters, which in turn would then basically reduce head height, because once you've got a deeper rafter, insulation and then plasterboard, you're losing head height. But what we've done in this scenario is it's kind of almost like 3 lofts in one. Now the reason being is, if you can imagine, we've got a steel beam there, separates that, we convert that. Mini area in between for the stairs, and then we've got another one here. You should be fine to crack on, lads. So yeah, so we're kind of converting thirds effectively. Now this side, they've cracked on massively. So we've got our eaves beam. This is what we refer to as a steel eaves beam. Now what we're going to have up there is a dwarf wall that goes alongside all these rafters. If you can see on this side, see, so we've doubled up the rafters. You should be right. Yeah. And then what we've got now is Darren is just putting the ceiling collar across. So these are all been spec'd, and I will show you. I'll show you the calcs in a second to understand that. But effectively, what you've got is a doubled up rafter. Stand this side so you can see it. Double up rafter. We're going to have an upright there, which will alleviate that angle one. So we'll have an upright there. Then you've got this collar that goes from left to right, and we'll have the same on this side. Design on this side is slightly different. The way that the architect has designed it is that basically we've got got joists running from the back wall plate to there. So if you could imagine, if you was to put timber from there all the way there, it'd be massive. Oh look, Darren's holding it up for us. So this is the collar I'm referring to. This is what we're going to have the detail up alongside. You can see here, this is the steel detail what we've got here, so the joist hanging down from that. Obviously this is the layout, so we've got the spine beams. We've got a centre floor beam to cut the span down. Now if I show you this side, this is where we've got our bit. So it says that we need rafters of at least 6x2s, 9x2s at 300 centres, which we've got there, as you can see. Collars to be bolted each side, so we're doing that now. Bearing plates and stuff like that. Thank you, Darren. So yeah, so we've got our joists at 600 centres, as you can see, 300 centres, as you can see here. Below here, you can't see it, but there is a steel beam somewhere there. So the idea of the steel beam is to split the span. So instead of having a joist run from there all the way along there, it would be a massive depth. So it'd be really deep, because the span from there to there is probably 6.5, 7 metres. So it'd have to be quite a sizable floor joist. But if we put a steel in the middle, what that allows us to do is keep the span and the joist lower. So I think roughly these are just shy of 4.2 this side, and then maybe 3.6 that side. So they're a little bit shorter. Now, I suppose there's a double edge to that, because you could put smaller joists in here, for example, but the headache we've always got is because we've got the spine beams here, that is our fixed point of height in the depth of the floor. So it's pointless us putting the floor lower, and then we're going to have to step over the ridge beam, the spine beam, if that makes sense. So we normally leave that for about a 10mm deflection gap over the top, so it just floats over. That's what we kind of typically do to design it. Now, as you can see on this side, it's not been converted yet at all. Obviously they've made the pocket holes ready for the steels, and that is one of the centre beams there with a splice detail. Got that eaves beam in there. So the plan of action is now they'll carry on through that. Once these collars are up and this dwarf wall is up, that basically and that dwarf wall obviously, that will allow for all of these trusses to be cut out. So as you see, Darren's got a laser level set up so we can get these all nice and level all the way across. As you can see there, he's actually using what we call a timber lock. So it's like a structural screw. Now, some people would do traditional method in the sense of bolting, so you drill an M10 hole and drill, whereas our engineer has actually specified, or spec'd at least, that we can use these in lieu of a M10 bolt, now, which is pretty handy because in reality it's far easier using stuff like this than drilling all the holes, because potentially when you're drilling, I used to do it when I was younger, is drilling with auger bits and you'd hit nails and it'd be a nightmare to then get the longer bolts in and stuff like that, whereas these are really good and make life a lot easier. So you see there, they're cracking on. So what we'll do is, now we've talked through the structure element, I think what we'll do is drop you another video in the coming couple of days and show you exactly what the space now looks like open. So hit that bell button, don't forget to subscribe. We'll see you again in the next video, and hopefully we should be able to show you a nice monster space down there. Enjoy.